Hello everyone. In the previous classes we have discussed about encoders and decoders, combinational circuits, and today we will be discussing about multiplexers, which is also a combinational circuit. So what is a multiplexer? We can see that here. A multiplexer is a combinational circuit that selects binary information from any one of the many inputs and directs it to the output. So with this we get to know that a multiplexer has many inputs and a single output. Now let us see the function of a multiplexer. Now I will be drawing the logic diagram of a multiplexer which has many inputs and a single output. So let me call the output as Y and let me call the input lines as I0, I1, I2, so on up to In. As I told you, in a multiplexer, one of the input line is selected and directed to the output. Now, the question is how the input line is selected. For that, we have something called as the data selector or the data input. So let me say I have many number of select lines. Let me name that as S0, S1, so on up to Sm. The relationship between the select lines and the multiplexers goes like this. I can say that if I have to have n number of inputs, then I should have m number of select lines where the relationship between the select lines and the inputs is 2 to the power of m is equal to n. If we have n number of inputs, then we should have m number of select lines. Let us take an example of a 4x1 multiplexer. In a 4x1 multiplexer, you can have 4 inputs and 1 output. Let me call the output as Y and the 4 inputs as I0, I1, I2 and I3. If I have to have 4 input lines, then how many select lines should I have? That goes with the relationship 2 to the power of m is equal to n, where n is 4. Therefore, what is the value of m? It should be 2 to the power 2. The value of m is going to be equal to 2. So I should have 2 select lines to select any one of the input and direct it to the output at any point of time. Let me call these select lines as S1 and S0. This is a 4x1 multiplexer. Now, the truth table for a 4x1 multiplexer. We have 2 select lines S0 and S1. At any point of time, what is the output Y going to be? If the select lines are going to be 0, 0, the select lines are going to select the first input and direct it to the output. So this is the connection that is going to exist. And what is my output going to be? It is going to be exactly the binary information that is present at I0. Therefore, Y is going to be equal to I0. And next, if my select input is going to be 0, 1, my output Y is going to be I1. I1 is directed to the output. Similarly, if the select lines are going to be 1, 0, my output is going to be I2. And if the select lines is going to be 1, 1, my output is going to be I3. This is the truth table of a 4x1 multiplexer. And this is how we denote the number of inputs and outputs of a multiplexer. You can have many orders of multiplexer here, like 4x1, 2x1, 8x1, 16x1, 32x1 and so on. The best real-time example for a multiplexer can be your television, where the television screen acts as the output. The number of channels that you can see on the television are the number of inputs of a multiplexer, and the remote control that is used to select these channels at any point of time acts as the data selector. Let us implement a 4x1 multiplexer using 2x1 multiplexer. First, we'll have to define how many 2x1 multiplexers are required to build a 4x1 multiplexer. For that, we have to take the number of inputs in the higher order multiplexer and divide it by 2 continuously until you obtain the quotient as 1. With that, we will get to know how many multiplexers, lower order multiplexers are required to build a higher order multiplexer. So, the higher order multiplexer here is 4x1. Therefore, the number of inputs in the higher order multiplexer is 4. So, I am going to divide 4 by 2. In the first step of division, the quotient is going to be 2. I am going to take that quotient 2 and divide it by 2 again, and now the quotient is going to be 1. Therefore, we need 2 plus 1. 3 2x1 multiplexers to build a 4x1 multiplexer. So, let us see how do we obtain that now. In a 2x1 multiplexer, we are going to have 2 inputs. Let me call this as I0 and I1. In the other 2x1 multiplexer, I am going to name the inputs as I2 and I3, because in a 4x1 multiplexer, we are going to have 4 inputs, which is going to be I0 to I3. And the outputs of these multiplexer, let me call it as Y2 and Y1. Now, we need another 2x1 multiplexer to combine these outputs and to get a single output. This is also a 2x1 mux, and my final output is going to be Y. So, here we have how many inputs here? We have I0 to I3, 4 inputs and a single output. So, this implementation gives me the 4x1 multiplexer. Now, how is this going to work? So, in the first multiplexer, now about the select pin, in a 2x1 multiplexer, if the input n is going to be equal to 2, then what is the value of m? It is going to be 1. So, this is one select pin here, another select pin here and another select pin here. But here in these two multiplexers, we are going to join these two select pin and take it as a single input. Now, whether I have to name the select pins as S1, S0 or S0, S1, we are going to decide that by seeing the operation of these multiplexers. So, what is the truth table of a 4x1 multiplexer? When S1, S0 is 0, 0, it is I0, 0, 1, it is I1, 1, 0, the output is I2 and 1, 1, the output is I3. Let us see the first operation. So, what is the what your output should be? Y should be equal to I0. So, therefore, let me say this select pin should be 0. Since we have connected both together, so this select pin will also be 0. If this select pin is 0, it is going to select the I0 pin and direct it to the output Y2. So, the output is going to be 0 here. Similarly, I0 here. So, similarly, if this is 0, I2 is selected and directed to Y1. So, this output is going to be I2. What is my output that what should my output be? That is I0. So, let us see, Y2 is going to be I0 and Y1 is going to be I2. So, if I want to select I0 as my output, this select pin should be a 0. If this select pin is 0, my output Y is going to be I0. So, I get the output as I0. This is the first condition of the truth table. Now, let us see the second condition of the truth table, where my output should be I1. If I have to select I1 from this 2x1 multiplexer, then this select pin should be 1 and similarly this select pin should also be 1. Therefore, if this select pin is 1, this is going to select the output to be I1, and similarly if this select pin is 1, the output here Y1 is going to be I3. Therefore, here it is going to be I1 and here it is going to be I3. So, what is the output that is required? It is I1. Therefore, this select pin has to be 0 to make my output Y as I1. So, it remains as 0, therefore, my output is I1 here. So, by looking at these two operations, okay, we can decide which select pin should be given which name here. Okay. So you can see that in the first condition, S1 had to be 0 and 0. So as here, this select pin was 0 for both the input conditions. Therefore, I'll name this select pin as S1, and S0 has to be 0 initially, and for the second condition it has to change to 1. Therefore, these select pins obeyed the condition. So I will name these select pins as S0. So this is the complete implementation of a 4x1 multiplexer using a 2x1 multiplexer. We also saw how it is satisfying the truth table. Similarly, we can implement a higher order multiplexer using many lower order multiplexers. Thank you.